Ellen, can you turn this light off, please? One of them, which one I don't know. Yeah, great. Thank you. Okay, so in our last class, I said we are going to do derivative to from graph to decide the derivative, like derivative of the function. We're going to do it later. First, I want to introduce you to implicit differentiation. Okay, so I'll give you some what to do, which you're going to do as a group, few questions, 10 of them, and then you'll learn better than when you study alone. But before we start, any question from anyone? Any comments? Complaint? I have complained. Your exam paper, I was kind of disappointed, to be honest. Everybody got something wrong except for Ellen. Everybody has something wrong. And especially the question about vertical asymptote, like 4, what's the limit of 4 going from the left side, from the right side? Many of you just substituted some number and said, well, that's the limit. But remember I said, when is the first step always is substitute the limiting value and see what type of problem you have. If you have 0 over 0, you modify and then you resubstitute. If you have number over 0, it means vertical asymptote. So limit will not be a number. It has to be infinity. Either positive infinity, negative infinity, or doesn't exist. You guys didn't follow that. So many of you got that question wrong. And another question wrong was, which one? Horizontal, the infinite limit. Okay, so x goes to infinity from left side, from right side. What many of you did, you substituted your x with infinity and said, oh, okay, we have infinity over infinity, so then say infinity. If you look at the lecture notes, I specifically gave you some rules about infinity. Infinity over infinity doesn't exist. We have no idea what is infinity over infinity. Same thing if you have infinity minus infinity, we have no idea what that is. Infinity plus infinity is infinity. But infinity minus infinity, who knows? Same thing, infinity divided by infinity, we have no idea. So I mean, many of you got that question wrong, and it was 7 times 2, 14 points. So you lost 14 points for nothing, just because you didn't follow, you didn't read your direction, or you didn't know how to apply infinite limit. The infinite limit follows the 3 horizontal asymptote rules. Okay, so I'm going to talk about that details later, but the whole day I was grading your exam and I was like, really guys, really? Is this what I taught you in class? It is really disappointing. So today we're going to start implicit differentiation. If you don't even know your derivative, it will be harder. So if you didn't understand your derivative part, make sure you ask me a question when you go over derivative part. And when I will give you the 10 question for you to do, please talk to your neighbors, work in a group, ask them how do you start this? Or once you start one step, what is the next step? Bug your neighbors, okay? You are here to bug your neighbors. When you're outside, you are outsiders. But when you're here, we are family. So I want you to bug everyone here, including me, so that you can learn your stuff, not struggle alone, okay? Implicit differentiation. So what is implicit differentiation? All these times we found derivative of function where y was the independent variable and x was the dependent variable. And if you notice, we could actually solve for y. All the questions we did so far, we were able to solve for y, or y was already solved for us. For example, y equals x, x squared, square root of x, all those functions, we had y one side and everything in terms of x on the other side. So we could find the derivative directly. And sometimes we cannot able to solve for y. So then how do you solve for, how do you find the derivative? For example, question like the next one, x squared plus xy plus y squared plus 2x plus 8. Come on, it's a long one. Can you able to solve for y here? We cannot. So when I cannot solve for y, how do I find the derivative? That is when you use implicit differentiation. The difference between normal or explicit differentiation versus implicit differentiation is two things. One is in normal derivative, we always had x independent variable. But when you do implicit, x will not be always the independent one. Sometimes other variables also will be independent ones. Like you may have x, y, z, and probably you're taking the derivative respect to x, or respect to y, or respect to z. It depends on what you're working with, okay? So we have different types of variable we take the derivative of, like respect to. That was one difference. Another big difference is that anytime you take the derivative of anything not respect to x, you have to indicate that. For example, if you take the derivative of y, you have to write, well, we take the derivative of y respect to x. How do we indicate? Either you write dy over dx if you have only two variables to work with. Like if your equation has only two variables and you're taking the derivative respect to x, then you can write dy dx or y prime. Either one is fine. But let's say you have three variables in your equation, and you are taking derivative with respect to only one of them. So when you take the derivative of each variable, for every variable you have to indicate this. If you're taking derivative of z with respect to x, we're going to write the derivative of z, whatever we have, and then dz over dx. Okay? So two difference. We can take derivative with respect to any variable, and whatever variable you're taking the derivative respect to, you must indicate that after you take the derivative of that variable. For example, we all know derivative of x is 1. That's why when you have 2x, its derivative is 2. Because 2 times 1 gives us 2. Same thing, derivative of y is also 1. So all this time you may not notice that when we had y equals x, we wrote derivative of y as y prime equals 1. What is y prime? It's a derivative of y. So derivative of y is 1, and we indicated that we took the derivative of y with respect to x, so it was y prime or dy dx. Now, if we have x squared, its derivative is 2x. Same thing, if we have y squared, its derivative is 2y. But in this section, we are taking the derivative with respect to x. So when you take the derivative of y squared, you write 2y, that's like 2x, but you have to indicate something extra. You have to tell this 2y with the derivative of y with respect to x. This indication, you must show it visibly. For x, we actually did put indication, but it is invisible. Let me show you how. So anytime we take the derivative of any variable, we always have to indicate that we took derivative of which variable and respect to which variable. Two things. So derivative of x squared is 2x, and we have something here, dx over dx. It means we took the derivative of x respect to x. But then what happens to dx over dx? Cancel out. That's why we never see dx over dx. Because when you have the same thing, they cancel out. So for x squared, we never wrote it's 2x dx over dx. We always said, well, derivative of x squared is simple 2x. Now for y squared, we cannot say that because we are taking the derivative of y with respect to x. So you have two different variables here. So derivative of y squared is 2y, and the indication is it's 2y. It's derivative of y with respect to the variable x. So now they don't cancel out because we have two different variables here. So it becomes visible. For example, x cubed, we said it's 3x squared, but then we had invisible indication, dx over dx. But we didn't write it because they cancel out. For y, we cannot say that. We have to write derivative of y cubed is 3y squared, and then the indication it's dy over dx. Same thing, derivative square root of x. We already know it's 1 over 2 square root of x. For square root of y is the exact same thing, 1 over 2 square root of y, but then the indication becomes equal. Okay? So that's the main difference between the derivative we did in last section and the derivative we're going to do in this section. In last section, we didn't have any indication because the indication canceled out anywhere. But here, the indication becomes visible. Okay? So we have to show that we are taking the derivative of y and we are taking this derivative with respect to x. In next section, when we are going to the related rate, we are going to take the derivative with respect to time sometimes, or sometimes with respect to some other variables. So anytime you take the derivative with respect to something, you always have to indicate what variable you took the derivative of and with respect to which variable. As long as they are not the same number, they don't cancel out, they become visible. So here we have an equation. X equals y cubed plus y minus 1. Find the derivative. Now to find the derivative, they didn't tell us, but we know in this section, all the derivative we're going to take will be respect to x. So x is our independent variable. So we apply d dx to both sides. Now what happens here? What is derivative of x? 1. And then we take the derivative of all the variables with respect to x. What's the derivative of y cubed? 3y squared. And then you have to indicate that either y prime or dy dx. Let's say I'm starting with dy dx so that you can see the indication. And then later I'm going to switch dy dx to y prime to make our life easier. And then the next one, y. What's the derivative of y? Just like the derivative of x. What's the derivative of x? 1. So what's the derivative of y? Also 1. But then we have to indicate that one we got, it's not the derivative of x, it's the derivative of y, which we took respect to x. And lastly, what's the derivative of 1? 0, it's constant. So for now, that's all we're going to do. Take the derivative and see every y you're taking the derivative of will leave some indication. In the next level, we are going to solve for dy dx. Okay? So just to recall, dy dx means derivative of y respect to x. Same thing, y prime of x is derivative of y respect to x. If you have f prime of x, it means derivative of f respect to x. So all these things, all those variables you are taking the derivative of are always respect to x. But it will not be true in the next section. So when they said find the derivative, in other words, they're actually telling us, hey, solve for your y prime or get your dy dx alone in one side and everything else to the other side. This is what find the derivative means now. In the last section, last section, we didn't have to solve we didn't have to put everything to one side because we already had y prime on one side or dy dx on one side. But now we're not going to have the same thing because if you observe, see we have dy dx in one side plus something extra. So we have to solve for dy dx, not solve. Yeah, we have to solve for dy dx by bring dy dx in one side alone and everything else to the other side. So the trick here is treat your dy dx as a variable. Okay, just think of it as a variable. And then that way you solve for any variable. For every step you take the algebraic step, you follow the same rules to get your dy dx variable alone in one side. And now let's do one complete equation. Find dy dx. It means get your dy dx alone in one side once you take the derivative of this equation. So dy dx, they're telling us that we are going to take the derivative with respect to x. So also I said another trick. Well, bring your y terms together in one side. In that way, you will be easily solve for dy dx. So before even taking the derivative, let's get the y's together and everything else together. So we can subtract the x cubed from both sides. So it will go from left to the right. And we can also subtract 3y from both sides. So the y will come on the left side instead of the right side. So we have 4y squared minus 3y on one side. We are happy because all the y's together. And then we have 16 minus x cubed. They don't have any y's. Why am I is always not straight? And now take the derivative. What's the derivative of 4y squared? 8y. But then you have to indicate what is 8y? What did you do? dy dx. If they mention dy dx, you should actually write dy dx. If they mention y prime, then write y. So whatever they mention, it's up to them. So take the derivative of y just like x, but then the indication comes. And then 3y. Carry. What's the derivative of 3y? Great. So it's 3 and then the indication dy dx. Sanjay, what's the derivative of 16? 0. And what's the derivative of x cubed? 3x squared. So they said find dy dx, means solve for dy dx. So if you treat dy dx as a variable, how are you going to solve it? Factor out. So you factor out dy dx, and we get what? hy minus 3. And on the other side, we have only 3x squared negative. And now the last thing you want to get the dy dx alone. So what do you have to do? Divide. So we divide both sides by 8y minus 3. And whatever we have, that thing is dy dx. Any question? Which equation?
Like when we transform 4y squared, we get 8y, 8y dx. Is it like, because when we take the regular derivative, f of x, or f prime of x.
Oh, no. Because here we already have two sides of the equal sign. So previously we had a function, while one side was y or f. Here it's not a function, it's an equation. It's equal sign with two different things on both sides of the equal sign.
So it's kind of like balancing, like so does it matter? Why?
If you take the derivative of x, it means you're taking derivative of x respect to x. So they cancel out. So for x, it's invisible. But for y or z or other variable, it's visible because you always write, well, let's see you found here, 8y. You have to tell, what is 8y? What did you do? So indicate, well, that at y is the derivative of y, and we took the derivative respect to the independent variable x. So for x, they cancel out, we don't write anything. But for other variable, we have two different d's on the top and bottom, so they don't get canceled out. Okay, so now they're saying find y prime, which is same. So the only difference is we don't have to write dy dx, we can simply write y prime. We find y prime for this. Musfika or Nicholas, do you guys have any question? Don't write in the chat box. I'm in the class. Unmute yourself and say something.
Hello.
Okay. Ready, guys? Xian. What's the derivative of 6x squared? Oh, before even doing that, let's bring y's together to make our life easier. So how do you bring y's together? What do you have to do? How? So you want to put y squared to the other side, no problem. And then 2 is a number you can ignore. 6x squared 2 plus y squared minus 5y cubed. So what's the derivative of 6x squared? It's the power rule. Power comes down, power minus 1. So what's the derivative of 6x squared? Now I'm talking about 6x squared. What's the derivative of 6x squared? You have your power comes down. So when power comes down, what happens to the 2 and 6? Do you multiply or do you add? Do you subtract? What do you do? Multiply. So you get 12 and then you subtract 1 from the power. So what do you have? X to the what power? First, so you don't have to write it down. Raka, what's the derivative of 2? What's the derivative of 2y squared? Sorry, what's the derivative of y squared? 2y, okay. And that's it? Y prime. You must. Ella, what's the derivative of 5y cubed? Negative 15y squared. Y prime. This is the main thing. You must put your y prime. Chi, right? No, or Hoy. Hoy. Okay. I get messed up Chi and Hoy. Okay. So Hoy, what do you do in the next line? How? So 0 is nothing. So what do you want me to write? 12x equals negative 15y square y prime. Okay, and then what? That's the wrong thing. Because your goal is to get to y prime alone. So if you want to get to y prime alone, what do you have to do?
May I answer?
Musfika, I'm going to ask you next, okay? So yes, you pull out y prime. So you actually don't have to write this line because the order doesn't matter since we are solving for y prime. You can do that, no problem, but you don't have to. So you pull out your y prime, and then what is left? What do you have if you pull out y prime common factor as a common factor? Why? 2y minus 15y squared. Perfect. Now, Musfika, if you want to get your y prime alone, what do you have to do now?
Basically for this, you divide both sides by 2y minus 15y squared.
2y minus 15y squared. Perfect. So we are done. Our y prime is whatever we have here. 12x divided by 2y minus 15y squared. Okay. So we need to do more work than what we did previously. That's because we have a mix of variables x and y. Any question? Now, what happens when we have x and y put together? What do you think? Good job. Since we have two variables, that means we have two different functions. X is one function, y is another function. So we have to use product rule. So let's say our f is the x function and g is the y function. So what is f prime? Andy, what is f prime? If f is x, then what is f prime? 1. Now, if g is y, what is g prime? dy dx or y prime? Good. I thought it was only one. You guys are smart. Okay, now product rule. Mac. Do you remember your product rule? F prime G and then plus G prime F. Perfect. So how are you going to write the product rule for XY? 1 times Y plus Y prime times X. Equals what? Really? 0. When you take the derivative of one side, you have to take the derivative of the other side at the same time. So it's 0, not 3. Okay. What do you do next, Ellen? Subtract y from both sides. So we get y prime x or x times y prime, doesn't matter. And then since our goal is to get the y prime alone, so we actually need to get rid of the x from both sides. So y prime is negative y over x. So x, derivative of x is 1, right? What is derivative of y? Also 1. 1. But then the indication comes. Because here it's dx over dx, but they cancel out, so there is no indication. But for y, we have to indicate that it's that 1 is from the y, not from the x. That's fine. Any other question? No? We could do that. Another way, as Ellen suggested, we have xy equals 3. Since I said get the y alone on one side, that means we can actually easily divide by x both sides. So we get y equals, and for this, let's convert into negative power 3 times x to the negative 1. So you can easily take the derivative using power rule. So derivative of y prime. And what's the derivative of 3x to the negative 1? Negative 1 comes down, and then negative 1 minus 1. So what do we have? What, did I miss something?
Over. Solve for, then you substitute back into y. You would solve for y there and substitute back.
Then why here we are missing a y?
You find y is 3 over x. You plug that back into stick there. You get 3 over x divided by x.
Oh, 3 over x is y. So
Yeah.
we get y over x. I see. Wow, I didn't realize that. But in the exam, I'm not going to give you something that is confusing. Like you can do 2 ways. In the exam, you have something more like this. Okay. So any question on left side?
Wait, like when we did Alan's method, we got like I know when you explained like the y equals 3 over x, but like then what's the answer?
So what is happening is this. We know from here that our y is 3 over x, right? And we found our y prime is negative 3 over x squared, which is negative 3 over x, or 3 over x times negative 1 over x.
Oh,
right?
I see, yeah.
But this whole thing is y. It's 1 times negative 1 over x, which is negative y over x. So if you solve for y, you get the normal derivative. But if you don't solve for y, we get implicit derivative, implicit one, like where x and y, we have both of them in the equation. But if you solve for y, you don't have the y anymore because you already solved before you find the derivative. Both of them are correct. Yeah. So if you can solve for y, go ahead, no problem. But if you cannot solve for y, then you definitely use implicit. Okay, any other question? No? Now, group guys, and do we have actually, let me put this on the other side. Including this. So we have 2 whole pages. What you're going to do today. The rest of the class is this. And once you're done with this, you're going to go related rate if you have time. Otherwise, have fun, enjoy. If you don't understand anything, ask your neighbors, especially Ellen. Bug him a lot. He's bored in this class. Ellen, do you mind if they bug you? If see, he doesn't mind. So he's like your tutor, okay? If you have any question, ask him. The more you'll bug him, the more he'll become smarter. Trust me.
over them all, I think, or what.
final. Right? So step one is 1.5. However, when we have that, that's the need to find out. It's up to you. Please follow the use product code. If you know just product code, then you just do. What is 0/60? Oh, wait. Sorry. It's called devil's card in the other.
What is it?
Well, that, I'm going to show the shape. It is some fancy shape. Why it represents general and morning. You want to swear in the one time. You guys should face one another. So you can have a conversation. Enjoy. And don't feel to the barrier. Enjoy your math. How are you? Um, keep your voice, but bring this alongside. You get to be really beautiful for one night. So, my friendship, what's the new between us? So the top one is question number 1, and then 2, 3, 4, 5. All these are different questions. And you're finding boyfriend for all of these. What is the size? Are you done? Wow, you did everything well. Tell me. In that is actually one of how are you? Let's see. I just actually got. But every Y, 50 Y, and the Y for that. So you must try to. Why did Y prime one? Y times 1 integrate to 87 Y. What did you do there? She did this one. Why should that negative four? You cannot subtract because this 40 is about to take this. So first he had to distribute. So have not but it also doesn't be so hard. So the solution is one line, like, why? How the solution is one line? Like, oh, it's quite. How do you do it alone? The second question. Why do you use that question? How do you have that question? It's like you're making a solution at the back of the book. You write as a solution from that. Like that. Then you answers the back on the you write in the books. Just the answer without question, without steps, without anything. So, I still want to see them. So, do you have? If you multiply the views, 412, views, H1 is 4, 65, and then 4 is and that's it looks good. Yes, what's it about? But anytime you can simplify over school. How funny those are really important. They say why you research. If you're not finding the why you flagging, you're finding a number for the vision. But you're not trying to find out number. You're trying to find low population. So coincidentally, they got the law, they got the numbers now, but in the life, they're not saying. study with the government virtue, or you study the children one. Little First why one so what why did you just what did you do? But if you want x, right? Just x plus y. And when you pick up the back, you can have just y x, right? It is changed. But why did you write only x instead of x plus y? Besides, you square root both x and y. So if you don't use chain rule, I mean, you must do chain rule, then you're going to write x plus y from 1 half power. So it's not only x, it's plus y. Whenever you have x and y together, which is which one? So y squared is 2y and y is the integration. Every time you break it y, you must. And then you have chain rule, product rule together. So you have 3, same thing power 2. And the outside is power, and then the inside. So you're multiplying here. So power 2. I mean that chain rule. It's the chain rule. Inside the chain rule, you choose the product rule for the first one. So you use your power rule as a quantity constant units to x times y prime plus y. And then okay, so you're using y prime here. No, sorry, it's not. So you have 2y. It's not 2y. Oh yeah, it is y squared. You actually have to write it here. You cannot just derivative one and eliminate the other one. Since this is the derivative of the second part, the first part must be the derivative of the first part. So, it's considered as wrong because when you do something, you should do everything at the same time. This part is correct, so you have to write your first derivative the first derivative of the first part here. And what they're saying, what they're asking for? The equation of the tangent. So you can try solving for y prime, but you have to because they give you the x and y value. So if you can substitute all the x and y here, you can easily solve for y prime. You don't have to solve it manually. Sure, because when you substitute all the x and y in these numbers, the only thing that don't have a number is the y prime. So that's all in y prime. And here it will be kind of harder to solve because you have to expand this fast, multiply these, it will become messy. Okay. you divide by 0, that means you also divide this by 1. So if you divide the whole thing by this, that means you also divide this by 1, right?
What is it?
Only this one, but not that one. Because if you class, so only divide individually. So dividing doesn't help. Instead, just substitute x and y. If you substitute x and y here, because they give you x and y. Substitute all the x and y, the only thing you cannot substitute is the y. So I do that solution. And moving forward.
How does it track?
You don't have to because it gives you less than 1. Anytime you cannot solve for y prime by they give you the x and y values, just substitute because y prime will be solved all the variables will be gone. So
So just find what is it?
y prime only goes to the derivative y. So you cannot got 2x by 5 with 2x dx over here. Dx over here because you cannot go over here. Y prime goes to the derivative y. Also, you do not take everything we know. What's the derivative we know? Which is product we have two functions x and y plus up to y. So you need to the product which is the derivative of the bit on side and the split inside. For example, f prime g times q plus minus good. So I just start one half. Stop one half minus 1. Again, and now it's going to be minus 2. What did you y?
What?
Yeah.
Oh, why? Why?
And see that one next to x is the derivative one, right? Derivative y. That's that one. So this is the derivative of y, right? So since it's the derivative of y, you must indicate that. Negative sign. Change. Partly the change for the outcome, but the change is the multiplied by otherwise it's 2. Mungkin sesi. Nah, kita 2y right prime. Vertical straight x removed by x plus side or right prime always simplify. Simplify. So I can number simple. So bad can do it just like that one. I say that. One thing you just take it away. Then you have to contrast to that. So let's say your f is GS. Something is really tough. So you have what is the X, right? And how come one of them is two? Negative. Ask you to find the derivative. Example. They already give you the y and the right, so find the derivative, right? So they give you x, they give you y. So they give you your a and they give you your b. They give you these two. The only thing they did not give you is the derivative. So first you have to find the derivative and then substitute it every and then find the derivative. This is not again. So what is derivative y squared? Only to y, not to y. Big time. Where we have v x plus x cube, and what happened to the rest of the chain rule? So you only use the power rule, but it's power rule and derivative inside. So how do you have this? Cosine x x y squared. So it is derivative y, right? Just y. It indicates see why it's very white. Okay, so I'm sorry, don't get white back because white back you just see what is happening. So this is x and each of the derivative is with x. So we have dx over dx and so on. And here, since it's y, so each of the derivative of y is dy dx. They don't get it out. So this is not right. So anytime the derivative of y, anytime you have to integrate that. That thing we have here is derivative of y and two derivative is with x. The here going to be y prime. All on. Bx y squared join this. Yeah. So already we have information so that it helps. I'm going to get the myself. So what y prime do it? And then 3 comes down to minus 1. So we use only part of the loop. The other half says it's multiplied by unity. And for that, that's why it's like but if you need to, use that, use that. Three comes down to change that times multiplied by the derivative function. You're going to multiply. What's the derivative? Derivative inside. What function you get inside? Write it just like this one. See, when you had xy, you had to use particle. So same thing with x1 here, that means you have to use a particle. Why are you using these? Why are you using this? What is that? Get to keep this. And it's not, it's times. Okay, so this is half of the division to 3 minus 1. And then you multiply by the derivative of this. So what is the derivative of this? And why is it equal to 1?
That's true.
Oh, finish something else. So we can go back and it goes to check to use y time for 1. So you have to get to y time for 1. Yeah, right?
Yeah.
So you have to distribute these. You don't have to expand. You can distribute these so that we have y squared. So that so in other words, the y out. So this whole thing multiplied first term, this whole thing multiplied. Why did you? Oh, because it is. adding first. Multiply. Separate. His goal is to separate the white prime. Don't put a multiplication sign, put a parenthesis. So in parentheses, also the white prime. She cannot take continue to distribute. She cannot. Because it doesn't stop. That's why we have to see what's. I don't even know what's. We took the pattern to that is alone. The various attracting. Pass is product rule, right? We need to pass times the second and the various attracting here. Product was about addition. So sign. This cosine and then you multiply this by the square. So you exponent. The only this is the derivative of the y. So derivative of y is 1 from 97. And then you got to y of 1. So the sine is cosine on the day side.
Okay.
Here.
Yeah, that's the same.
Sine y squared and then
Yeah.
y squared. Yeah.
Oh.
What if it's that's here? So if x is 1 and then you like to and then number 2 is might be 1. See on the 1 looks like 70. Must be a fraction of a so if you don't want a fraction of a fraction, maybe also need to make them. We don't have to do it. Yes. Sons, plus that's right.
Yeah.
They just how did you go? Okay, let's do them together. Now what? These.
No, wait, this. This is the past.
Right.
Okay.
Where?
Right? And the big color, yeah, it's clear. Yeah. Fine. Yeah. I should have plugged in just
And it's not twice for that, it's
Great.
twice for that.
Oh, I love it.
He's not here.
After looking.
It's not simplified.
Yeah, like how do I simplify?
And it is the common denominator here.
Oh.
And then you come back to the denominator, this denominator type, whatever. Okay, then let's see. So the first one, they have y's together. We can simply take the derivative. We get 3y squared. And since it's y, so we have to indicate with our y prime. Then here comes the product rule. So if f is x and g is y, we have f prime simple one, but what is g prime? Y prime. So it's like one only, it's one and then y prime. And since you're subtracting, so the product will be subtracted instead of added. So we have f prime g. So 1 times y plus, but since you're subtracting, so you become minus x y prime. And what happens to the derivative of x squared? 2x. And then what do you do? If you want to do everything together, you add y to both sides, so the y cancel out. And then you see we have y prime at the same time. So we can pull out y prime. We get 3y squared and minus x. On the other side, 2x and plus y. And then we don't need this 3y squared minus x. So it divide by 3y squared minus x. And this is our y prime. It was easy, right? Does anybody have any question on this one? No? Now this one is interesting. Either you can use quotient rule, or you can use product rule, or you don't have to use any rule if you multiply both sides by y cubed. So let's multiply both sides by y cubed. You don't have to use neither quotient nor product. If you multiply by y cubed, life becomes easier. We get x equals to y cubed. What's the derivative of x? 1. And what's the derivative of 2y cubed? 6 y squared, and then y prime. So what is our y prime? 1/6 y squared. If you multiply, it's only two-line equation, two-line solution. And this is the graph of the next one, devil's curve. I don't know why it's devil. So if you look at the curve, they're saying, what's the slope when 0, -2? So 0, -2 is here. When x is 0 and -2 is here. From the curve, you can automatically see that here we have a horizontal tangent line. So obviously our slope here will be 0. Okay? So by looking at the graph, we know the answer is 0, but they don't want us to use the graph, they want us to use algebra, sorry, calculus to figure this out. So we have y squared minus 4, x squared minus 5. Yes, you can use product rule on both places, but why you want to make your life harder? You can simply distribute them and all of them become easier. So we get y to the 4 minus 4y squared, x to the 4 minus 5x squared. And also we have all the y's one side, x one side, so it will be easier. So what's the derivative of y to the 4? 4y cubed, and then y prime. What's the derivative of 4y squared? 8y, and then the y prime. And the other side is 4x cubed minus 10x. To get the y alone, we can take out the y prime as a common factor. I can divide both sides by, since I'm too lazy, let me just divide. We divide by 4y cubed minus 8y, right? And this is our y prime. But they said once you find the derivative, tell us what's the number, not the equation, what's the number for that derivative. So x is 0. And when you notice when x is 0, this is 0. Actually, let me write it on the next line. When you have x 0, the first portion is 0, the second portion is 0. So we have 0 over 0 over a number. So what's the derivative? 0. Any question? The next one, same thing, find the y prime when x is -1 and 2. So do the same thing. We have y squared one side and 5x to the 4 minus x squared. So derivative of y squared is 2y, right? And then the indication y prime. And how about the x? What's the derivative of the right side? 20x cubed minus 2x. So what is our y prime? 20x cubed minus 2x divided by 2y. And you see already that all of them, they are even numbers. So if you want, you can just write 10x cubed minus x over y, because all of these are divisible by 2. And our x is -1. So 10 times -1 square minus -1, and our y is 2. So what do you have on the top? Did I do something wrong?
It's like, you know, I square.
Q, so -10. So you have -10 plus 1 over 2, which is -9 over 2. All of this seems so easy. Then when I checked your work, I saw so many hard works. Why is that? You know, checking your work actually gave me a big headache. My head is hurting so badly now because I saw a bunch of hard works. Let me erase this. The next one. So in the exam, I'm going to ask one of these, where you choose product rule. Not easy like those. Those are too easy. I'm going to give you something where it's easy, but little bit complicated also. So we have y's together, but we also have an extra x. So let's bring the x from left to the right. So we have 3xy minus y squared, and then 4 minus 8x squared. This is an optional step. You don't have to do it, but I like to do it because I have my y squared together. Sorry, I have my y prime together at the end. So, what do we do here? Product rule. So let's say our f is 3x and g is y. Then what is f prime? 3 and g prime? Y prime. So how are you going to write the product rule? Tell me the answer. Anybody who wants to give me the answer? Jocelyn, you go ahead. 3, hold on, I'm writing it down. 3x y prime plus y2. Did I miss something? No, right? 3 and 3y, right? And then you have, what's the derivative of y squared? Y prime. Andy, what do you on the right side? We have 4 minus 8x squared. So when you take the derivative, what do you have? Negative 16x. I'm ignoring my 0. And then what do we have? We subtract the 3y, right? And we take out y prime as a common factor. So we get 3x minus 2y equals negative 16x minus 3y. And what is our y prime? I'm too lazy. Let me write it here. This is the y prime. What goes in the denominator? 3x minus 2y. Do you guys have the same answer? Or did I make any mistake anywhere? Same answer? And I have another extra page. Now it says find the equation of the tangent line. So derivative of y squared. What's the derivative of y squared? 2y and then y prime. And now comes the interesting part. What happens here? Apollo. Chain rule. So tell me the chain rule, please. Uh-huh. Mm-hmm. And so divide dx, let me write y prime because I already wrote y prime in the first one. So in other words, you use product rule for the middle, for the first one. So derivative of x is 1 times y plus x times derivative of y, and then you have plus 0, but you can ignore your plus 0. Equals, what is derivative 2? 0. Be very careful. From my experience, I've seen that people actually forget to take the derivative of the number. So they write, this is 2, and then they do all the work. And then at the end, the whole thing is wrong. So be very careful. And then I saw a common mistake. Common mistake was it divided everything by 3xy plus 1 square. It definitely cannot do that. Why not? Because see, the middle term has something in the front. So division doesn't allow division. We are not allowed to have a division here. So you actually have a couple choices. What do you think is the easier way? Plug the point. Yeah. So when you see things getting complicated, make it easier by substituting. So here you're lucky because they gave us the point. You don't have to do anything. But if they tell you to solve for y prime, then you have to think harder which one is easier. But here, don't wreck your brain. We are already too tired. So we have y is 1 and all the x is 0. Y is 1 and all the x is 0. So if we substitute, we get 0. This cancel out. We have only 1 square, which is 1. So here we have only a simple 3. Here we have 2 times 1 y prime, so it's 2 y prime. Because our y is 1. Times, here we have 1, and then since our x is 0, so this actually gets vanished. Now see how easy it is now. So subtract 3 from both sides. So our y prime is negative 3 over 2. But we are not done because they said find the equation of the tangent line. So equation of the tangent line is tangent line. Y equals derivative at a x minus a plus the y value for x a. So derivative at a is negative 3/2. Our a is 0, so x minus 0. Our y value when x is 0 is 1. So in other words, it's a simple negative 3/2 x plus 1. Instead of this, let me just highlight. Do you guys have the same answer? Ooh. All of these are too short now. Come on. Now comes trig. Anytime you trig, most of the time you have to use chain rule. Most of the time. So we start from here. What's the derivative of 3? 0. Derivative of 5x? 5. And then comes the chain rule. First, we take the derivative sign. What's the derivative sign? Cosine. But leave your inner function same. You're not allowed to change two things at a time. So we took the derivative of sine. We are done with that. And now you have to take the derivative of xy cube, which is a product rule, right? So let's say f is the x. Actually, let me do it here. F is the x, and g is the y cube. So what is f prime? 1. And what is our g prime? 3y squared y prime. So chain rule says when you are done with the first function, then you have to multiply by the derivative of the inner function. So what's the derivative of the inner function? What do you have? Anyone? Do you want me to call your name, guys? Or any volunteer? Why I forgot to call attendance today? I'll do it after this one. Go ahead, Apollo. So let me write the x next to the y. And then let me write y prime instead of dy dx. So the product rule says f prime g plus g prime f. So f prime is 1, g is y cubed, g prime is 3y squared y prime. Our f is the x. When you put them, looking at 3xy squared is nicer than the other way around. And here it says solve for y prime. So you have to solve it. And now, depending on which method you use, you get a different answer. So if you divide it by cosine, at the end you get the correct answer, but it looks weird. So what you can do is you can actually distribute so that it look not weird. We have 5 equals y cubed cosine xy cubed plus 3x squared y prime cosine x y cubed. Well, let me create y prime later. Cosine x y cubed and then the y prime. And now it will not look so weird. So our goal is to get this alone. That means we need to subtract the first term and divide it by the coefficient. So at the end, our y prime is 5 minus y cubed cosine x y cubed. So we subtracted this amount, and then we have to divide the result by this coefficient. So divided by 3x squared y cosine x y cubed. Now it doesn't look so bad.
Get points off you right though, right?
But it's just your satisfaction. Like when you looked at year one, everyone's telling me something looks bad, something looks bad. But look at this one, it looks nice. Smooth. And I have another page. So let me get rid of that. Okay, so again, you have to use product rule because they both have two functions. So for this one, for the first one, let's say f is the y and g is the sine x squared. That means our f prime is what? Y prime. And g prime is chain rule. What's the derivative of sine? Cosine. Leave your inner function same. And then you multiply by the derivative of the inner function. What's the derivative of the inner function? 2x. So we have f prime g. So we have y prime. For this part, y prime sine x square you must, because you have two different functions. Anytime you're working with two different functions, you always have to start with chain rule, product rule. Inside the product rule, the chain rule comes, but product rule is first. So product rule says first function derivative times the second plus keep your first function and then derivative of the second, which is, let me also write. So I'm combining my 2x with the y so that it looks nicer. We get 2xy cosine x squared equals, we do the same thing on the other side. We have two different functions. Two different functions automatically means product rule. So derivative of the first one, 1. Keep your second function same. And then plus the first function, derivative of the second. So if we have sine y squared, derivative of the sine is cosine. And then we take the derivative of the y squared, which is 2y y prime. So you multiply that by cosine y squared 2y y prime. And let me actually rewrite this. Let me write 2y next to the x. So 2xy and then the y prime. I just rearranged them. I did nothing. Just to make it look nicer, I put 2x next to the y and the y prime the last thing. So we see we have one y prime here, another y prime here. That means we need to combine them. Let me actually get a page here. It looks messy. So we have sine x squared y prime, and we are going to subtract this amount. So minus 2xy cosine y squared y prime. And then on this side, we don't want this. So we're going to subtract this from both sides. So on the other side, we have negative, no, we already have sine y squared, which is this. And now we are subtracting the 2xy cosine x squared. But fortunately, we see our y prime directly. So we pull out y prime, and we get sine x squared minus 2xy cosine y squared. And the other side stays same. Sine y squared minus 2xy cosine x squared. So we need to divide both sides by this. Divide. So we have sine y squared minus y cosine x squared, whole thing divided by sine x squared minus 2xy cosine y squared. Wow, they're the exact same thing, just their angles are different. On the numerator, we have y squared first and then x squared. And then here we have x squared and y squared. I don't have a space horizontally, so I wrote them in 2 lines. But in your notebook, you have enough space, so write them horizontally so to look nicer and it will make sense to you guys more. Did I make a mistake? Is the answer correct? Ellen, what do you have? Same answer? Okay. Can I stop here? My head is hurting so badly. So I will stop here. And it's only 4 minutes over. So the plan for Monday, I'm going to send you a video link to watch. And I'm planning to get the video for linearization, which will be our next section. So I want to do related rate with you guys in person so that we can enjoy. But linearization, I'm going to give you a link for linearization. So you're going to watch either next Monday or anytime before next Wednesday. So I'm not going to have any lecture on linearization, okay? Because I'm going to give you the lecture by you. I'm going to send you the link so you have to see it by yourself. And whatever questions you have, we can discuss that in person when you come back. No, I am almost done grading. I have to grade only 1 page for everyone. So I'm going to give you exam back next Wednesday, definitely, inshallah. So enjoy everyone. Remember, tomorrow no class. We're supposed to have a class, but tomorrow we're not going to have any class. Oh, I forgot to take your attendance. Hold on. Kimberly, absent. Kerry here. Judith here. Matt here. Zia, absent. Chi, absent. Jocelyn here. Lucas here. Hoy, Logan, Ellen here, Mustika here, Nicholas here, Sanzim, Shian here, Raka here, Ella, Apollo. Okay. So goodbye, everyone. Have a good weekend. See you after 1 week.
Bye.
Bye, Musfika. Bye, Nicholas. Andy, make sure you